Okay, for those of you that just came in, this is COP 2800 Java programming. If you're not in the right place, feel free to switch rooms now. Hope everybody's having a good semester so far. We're going to keep it pretty light today. Just talk about a lot of the things that you need to know to get started in the class. There's probably going to be, reading material and things you're going to have to get into in the textbook. But for now, I just want to make sure everybody's able to access everything and you know what's there and that it's all working. As you can see with the little technical difficulties we've had here, it's not unusual to have stuff that we have to resolve when we get started each semester. And so thanks for bearing with me, and, additional patience requested when we run into other glitches and stuff. Again, never fails that we start getting into Canvas and realize, I didn't update that for this year or this semester. So feel free to just point those things out and I'll get them corrected as soon as I can. And we'll just go from there. So you can see what we're going to cover tonight. Like I mentioned, probably not going to be a full 3-hour class tonight. Most of our courses will be sort of that format. We'll have some kind of a lecture to get you guys introduced to the course, and then there will be lab time at the end for you to spend time in here. Some people prefer to do all their work in here where we got the nice computers, nice quiet environment, me to answer questions if need be. Other people like to just give me the assignment, I'll get out of here and I'll go work at home. You got that flexibility. So having said that, let's just jump right into it. So this is the book. Hopefully you recognize it. Don't see many people around with the hard copy these days. Anybody get the hard copy of the book? I don't even think the publisher gave me a hard copy of this book. I have to read it online also, but that's pretty much standard. Hopefully you can get to this through going to Canvas and clicking through the either the Cengage link or clicking on the assignment under modules that says read this chapter, and that'll take you through. Just to help you out with other software packages, we focus on Canvas primarily at FSW. When you get into the course, there will often be an integration with some other tool. For in here, it's Cengage, because that's where you get your textbook. So often you need to click on the individual link to get from Canvas there, and in that handoff they provide like the course identifier, maybe my identifier, but whatever that other system needs in order to route you to this class on their system. And that way everything's hooked up, and you're, if there's grades coming back, they come back here to Canvas. If, when you're going over there, you get to the right place. If you're ever seeing something where you go into Cengage and it says, who are you? What class are you enrolled in? Enter a course key or some other kind of piece of information. You probably didn't go through the link to go from Canvas into that system. I teach several classes, and they use different software packages to integrate learning material, and they all seem to work in the same way. So I would say your standard method of accessing the textbook is going to be go under modules, click on the read chapter such and such link, and it'll take you over to Cengage, the appropriate way to get to the chapter. Okay, first week stuff. If financial aid is a thing, you want to make sure that you do the attendance verification quiz. Another thing about the way things work at FSW, if you go into one of your classes in Canvas, I think I fixed that in this one, so it's not an issue here. But if you go in there and under modules, you see 2 first day of class quizzes. One of them is probably a copy paste from the previous semester. Because when we copy a course, like when I copy last year's course to this year, it brings over all the links under modules, one of them being the attendance verification quiz. Well, and then the IT department comes along and they push a new attendance verification quiz to every one of the Canvas courses, and now we've got 2. Some of these courses I've gone into, and they've got 3, maybe 4 different attendance verification quizzes. Me as the teacher, I'm supposed to be able to go through there and say, this isn't the real one, this is not the real one, and delete them all. But just look for the one that's the right one, and if you have to take it more than once, it's not worth any points. It's just mainly to show the university that yes, I came to this class, yes, I clicked on the quiz, no, I'm not a robot, that kind of stuff. And that turns on all the bells and whistles in the revenue department so that financial aid and all that kind of stuff gets cleared up. So first week of school stuff, just go do the attendance verification quiz. Make sure you can get to the textbook. Like I said, don't click on the Cengage button necessarily. Click on the Read Chapter 1 link under modules. Okay, so that gets us to the next thing. You're going to have files in here. In Java programming, we're creating source code, and the source code gets stored in files, and the files end with the .java extension. So one of the things you need to figure out and start getting familiar with the first week of school is, where am I going to put those files? If you do your work in here and you save the files to this computer and then you leave the classroom, every time these computers get rebooted, they get wiped back to a common standard image. So all the files on the computer go away that you added. So if you leave the room and you come back and the computer's been restarted, your files are gone that quick. If you have an issue on your machine and you think, oh, it's screwed up, I just need to reboot the computer, all your files just went away. Okay, just be aware, that's how these machines work on campus. So, flash drive, we'll talk about other ways of managing your files, but have some way that you are comfortable with of bringing files that you have worked on before to class and saving the files that you work on in class so that you can bring them home again with you. Same thing at home. I do this too. I'll be working on a PowerPoint or something for class, and I'll leave it on my computer at home, and I'll get here and it's like, dang, I don't have that file. So I need to do that too, so something you have to just get used to. We're probably going to use something called GitHub, where you can store your files in your account on GitHub, and then you sync with that repository when you get here each time, continue working, push your files back to GitHub, and then when it comes time to get graded, sometimes I will ask for the Java file so I can look at it. Sometimes I'll just say, give me a link to your GitHub repository, and you can send that to me and I can go to GitHub and look at the file and see what you've been doing. But that's a thing. Just get familiar with how you're going to manage your files. Submitting assignments, we typically do that through Canvas. So whatever the assignment is, you'll just click on the link under modules for the assignment and you'll upload your file and hit submit. One of the things that I like to point out, you'll probably forget this until it matters, but let's say you're turning in an assignment that has 3 files. In COP 1000, it's common, we'll have a flowchart, pseudocode, and Python file to turn in, 3 files. Then 10 minutes later you'll realize, oh, I needed to correct this, and you'll upload your Python file again. Well, your pseudocode and flowchart are gone because it only contains the set of files that you last submitted. I can't see what you submitted last time. So every time you submit those files, if there's multiple files, submit all the files each time. Okay? Like I said, you'll probably forget it until it matters, but at least I have said it to you that when you're submitting things in Canvas, submit all the files every time. Grades, so all of your grades will be recorded in Canvas. So you see that little grades link on the left. And hopefully this is all just repetition for those of you that have had courses of mine or other courses here at FSW. But in case this is your first semester at FSW or you've forgotten over the summer or whatever, all your grades will be there in Canvas. So one of the things to remember about that is we don't have that problem in here, but when Canvas is linked to these other systems, there's a delay sometimes in the other system reporting its grades back to us. So you have to just sometimes wait 24 hours and see if your grades get posted. Like I said, I don't think that our class has any grades like that are going to be reported back to Canvas from some other system, so it shouldn't matter, but maybe it'll help you in another class. Welcome. Sit anywhere. Yeah, so the modules tab in Canvas is pretty much your course outline and the guide for what we're doing. You're not going to hurt my feelings if you work at your own pace and get a little bit ahead. But just be aware that sometimes I update things as I go, and even though you may see content out there for future modules, when we're actually talking about that unit in class, you should regularly check that module and see if there's been any updates. Don't think, well, I did module 2 a couple of weeks ago, so I'm already done with that. No, when we're talking about it in class, go back there and make sure I didn't add some supplemental reading that will be on the quiz or updated the quiz, or that happens very rarely, but something like that. But I reserve the right to make tweaks and corrections as we go. I won't wait till the last week of school and go back and change stuff on week 2 and pull the rug out from under you. That wouldn't be fair, but just be aware that Canvas can change as we go if I find the need to do that. The other thing is the office hours. We generally have time in class to resolve issues that you're having with a tool or trying to figure out something in particular, and so usually, traditionally, there's time in class to work out things, but if something happens between class times that you need to talk about, or you don't want to bring it up in class for whatever reason, that's fine. I have posted office hours every week, and I live an hour away, so whenever we can do it over Zoom, that's great. If meeting in person isn't required, but finding out when I'm available and how to contact me is something that you should know. The information about my contact stuff is in the syllabus. There's also a piece of paper outside my office upstairs that has my office hours and stuff. And one of the things that I'm experimenting with, we'll see how well it works. If you come to Canvas and you click on the instructor link, there's this QR code that'll take you to the page where you can book time. It saves a lot of time, because what people usually do is they'll email me and say, hey, can I meet with you? And I say, sure, when are you available? And they say, I'm available on Friday. And I say, well, I'm only available on Thursdays. And there's a lot of back and forth. With this link, you can just go there and say, oh, there's a 20-minute slot, boom, it's mine. And we're on the calendar, and if I've said the slot's available, that's on me to make sure that I'm available to meet with you at that point. But like I said, I'm experimenting with that. It's the first semester I've used it, so growing pains might be possible. But hopefully that'll be pretty easy. You can just scan that with your phone and open it up and book something if you need to. Yeah. Any other questions about Canvas and in general, what we've talked about so far? Okie dokie. So a little bit about me. I don't talk about myself much because I don't find me that interesting. You can see my LinkedIn profile if you want to know where I've worked and some of the stuff that I've done. One of the things that I noticed as I started getting older is you go back to places that you thought were significant landmarks from your childhood, places that you hung out a lot, malls where you spent time, or different things like that. And I keep going back to those places from my lifetime, and they're not even there anymore. Like they've dozed the entire mall, and now it's trees again or something. It's just like the whole history is completely gone. And it's kind of the same with programming in general. We live in the virtual world. We write software, we write all these lines of code, and we focus on them and spend lots of late nights and blood, sweat, and tears coming up with these algorithms and making them work correctly. And then the next programmer that sits down in the chair hits the delete button and it's all gone. That's the way software works. So, I've worked on some stuff that I thought was pretty interesting at the time. I'm more than happy to talk about any of those things if they're of interest. But there it is. As far as the relevancy to you and your career and what you want to do, it's only interesting if you think it's interesting. So I won't go into it too much unless you have a question about it. I've done lots of different languages. They asked me when I started here what classes I wanted to teach, and I'm like, I don't know, what do you got? I could probably teach anything in the catalog if you wanted me to, but different teachers have different specializations and different things that they prefer. I'll let you know, I like these programming classes. I like working with people who have either never programmed before or are learning a new language, and I get a kick out of seeing the light bulb come on. So I enjoy helping people that are trying to figure this stuff out early in their career. So that's one of the things that I like about teaching this kind of a class. So then we get into, hopefully this is review. Again, unless you have tested out or skipped the intro classes and you're just jumping right in with both feet to start learning Java. Again, hopefully this is review. But as a reminder, we are developing algorithms. So yes, we're trying to figure out how to program in Java, but what's the point of that? It's like learning Spanish if you never talk to anybody that speaks Spanish. Well, okay, as an academic exercise, it was interesting, but was it practical or useful? And it's the same thing here. We can learn Java all we want to, but unless we are intending to use it for something, what good was it? Was it just a waste of time? So we focus on algorithms. There's a good example, I guess, is the Towers of Hanoi. Has anybody ever played that? The little thing with the 3 sticks and the little donuts that you stack up on there. And you have to think, how am I going to solve this problem? How am I going to get all the disks from this pole to this pole when I can only move one at a time and I can only put smaller disks onto bigger disks? And in your mind, you come up with an algorithm for what order to do that, and it takes a while for it to run, lots of iterations, but then eventually, if you follow that algorithm correctly, all of the disks get moved from one pole to the other. That's a really good example of an algorithm that your brain has to solve, and then it has to be executed in order to solve that problem. Well, we do that a lot in here. One of the interesting topics for us to discuss, hopefully we'll have chances to get into this as we go through the semester, is what's the point of learning programming anymore when companies are just going to use AI to replace me anyway? They don't really need me, do they? It's a great question, because another analogy, back in the 40s, 50s, 60s, early in NASA in the space program, has anybody seen that movie, what's the name of it? The one, Hidden Figures or something like that, with they had the human computers, is what they called, that was their job title, but they would be given math problems and they have to solve these math problems so that the spaceships would know when to turn the engines off and all that kind of thing to get the ships to space and back home. There were some really interesting math problems, but back then they had slide rules. They didn't have, the computer tools that we have, and they had to use their minds to figure out these math problems and solve them. So we had lots of people, like maybe a room full of people sitting there computing algorithms. One of the scenes that I remember from Apollo 13 movie, I think it was, with Tom Hanks, is he was sitting there and they were all sweating. They were worrying, how to get home, and he said something about, guys, I'm getting kind of punchy here, so I need somebody to check my math. And he reads off some numbers, and you see this whole row of engineers in the NASA control room, and they all get out their slide rules, and every single one of them is doing the same calculations he is on their slide rule, and they all give a thumbs up when they get the same answer that Tom Hanks did, right? Okay, I say all that to say things used to work differently. We used to need people to solve these math problems, and even though everybody knew how to do the calculation, when it came time to know what the actual answer to this problem was, a person had to pick up their slide rule and solve that problem to get the answer. Calculators eliminated that whole job from being needed, right? Now we can just punch it out on my calculator and I get the same answer every single time, and I don't have to worry about whether it's wrong. So Tom Hanks gets a thumbs up pretty quick. Same thing we're dealing with here in computer science. These algorithms have been trained on what thousands of programmers have produced in terms of software. A number of years ago, Microsoft bought GitHub, which immediately gave the company access to millions of lines of source code that other human programmers had written in the previous 10, 20 years, which gave them the ability to write AI and train it on that software. So if it says a comment in the source code that says sort 10 numbers, and then it sees a number of lines of code, it can assume those 10 lines of code sorts those 10 numbers, right? And so you train that over thousands and thousands of lines of code. So now when you ask the AI to say, hey, can you give me an algorithm in Python that sorts 10 numbers? Yeah, it spits it out. It didn't invent it. It didn't think of it. It just referred to all of our source code that we'd written over many years to quickly give you the answer. It's a very useful tool, very helpful. It lets programmers like us be very, very productive and very accurate in our work. Sound familiar? Like with the slide rule? I don't have to have 10 engineers with their slide rules doing the same thing to make sure all 10 of us humans got it correct the first time. I can just ask the calculator. And same thing, I don't have to sit there and pore over the lines, the semicolons and the curly braces on the algorithm. I can just ask the AI and get a reasonable facsimile of it to start with. But I'll tell you, the AIs are still not perfect, and even if they claim to be better than the one before, they're still not perfect. They hallucinate all the time. I get the wrong answer as often as I get the right answer from them. I mean, granted, maybe I'm asking more difficult problems than they are, but my assumption is that you guys aren't going to go out there and solve the same problems of 10 years ago. You're going to be solving the problems of 10 years from now. There's no GitHub repository that has the code for those problems in it already. So I feel like there is going to be a role for software developers, programmers in the future, but we're going to have to compress a lot of this stuff. Maybe in a couple of years, we don't have a Java programming class. We have an algorithms class, and you ask the AI to produce Java code to solve this problem, and we talk about the dynamics of the solution. It may change. But for now, we're all just kind of riding this wave to see where we end up. Any questions or comments or things that you've seen in that regard? Because, you guys are, I'm just one person out here, and I'm staying up with the news and the trends and the new AI models that come out. But in a lot of ways, I'm going to be relying on you guys to feed me what you're seeing out there too, and what your thoughts are. And I'll be better able to change the curriculum here to match what you guys need if I understand what it is you do need. Especially if you were to graduate in the spring and go off to get a job and get a year or two of experience, and you think, wow, I wish Dr. Snyder had told me this when I was in his class. Well, shoot me an email and let me know, hey, by the way, this is important now to us out here working in these jobs. You might want to be telling the new students that they need to pick up these skills, or this is how they're going to be using these skills. Because that's useful for us to know to help us help you and the new programmers coming out. Because I don't want to be sitting in an office with a Terminator robot as my boss. That doesn't sound fun. I'll tell you another little story while we're on the topic. I I mean, forever ago, back in the olden days, I was working at Microsoft and I was in the games division. So I got to, talk to a lot of people that were really creative people developing new games and stuff, and it was a fun time. But one of the things that they would do is they would have people that a certain team was working with, they would come onto campus and you get to talk to them. John Carmack and different people like that would come to campus and they'd talk to people in the games division once in a while. It was pretty interesting. But one of the guys that came was a guy named Gary Kasparov. Has anybody heard of him? He's a old chess player, but he was, one time he was the best chess player in the world, and he was working with IBM, who was developing an algorithm called Deep Blue, which they were trying to say could beat any human at chess. And Gary Kasparov thought that was an interesting problem to work on, and he paired up with them, gave them a lot of notoriety and publicity for it. But then it came down to they were testing the algorithm. They thought, well, we're getting pretty close, and they were testing the algorithm. And he got mad during one of the matches and stormed off, and he said, I'm done with this. And everybody said, oh, he's kind of hot-headed, so he probably just got mad because Deep Blue was about to beat him, and he didn't like that. It hurt his ego. And, well, he came to Microsoft, and he was talking to a group of us about those experiences, and we were asking him questions. And somebody asked him and brought up Deep Blue and that whole kerfuffle, and he said, I'll tell you what really made me angry about it. He said, we discussed who is the best, what kind of player is the best player at chess? And he said, my opinion is the best player at chess is a human assisted by a computer. So if Gary could sit there, he's a really good chess player, and he had a computer that he could ask, hey, I'm thinking about this move. Can you give me all of the, give me a grade from A to F on how good a move you think that is. If he had tools like that where he could interrogate the potential moves, then he would be better than everybody else. And so he thought that was an interesting problem to work on, so he was trying to help Deep Blue improve as an algorithm. But he said, based on that philosophy, that he knew that he could set up scenarios with Deep Blue where he could trap Deep Blue, where he knew how Deep Blue was scoring the moves. And he said, well, I'll set up a situation where Deep Blue is likely to pick this move, and then I say, aha, I got him, and then he would win against Deep Blue. And then they incorporate that into the feedback, and hopefully Deep Blue would get better and it wouldn't fall for the trap next time. Right? That was the game he was playing. But it turns out the IBM people behind the scenes in the back room, they had 4 or 5 grandmasters sitting back there in the back room, and they were watching the moves that Deep Blue was about to make and changing it. So just so that they could beat Gary Kasparov. Because that's the headline they wanted. Deep Blue beats Gary Kasparov. And that made him mad, because he said, I've already admitted to you that if I was playing a grandmaster assisted by a computer, they would beat me every single time. That's not an interesting problem to me. I know that's true. He was interested in helping them help improve Deep Blue. Okay? So I apply that similarly to us as regular old programmers trying to sort a bunch of numbers assisted by an AI that will help us quickly do the tedious things, the boilerplate code, and then let us get to the interesting part of the problem where we have to do something creative or invent something new or solve a problem that we don't have a bunch of code out there already for, and we'll be so much better because we're a human assisted by this AI that helps us write the code. So that's the way I look at it, and where I see a lot of the promise in the future. So, sorry for the aside. You'll see that that's pretty typical. Yeah, that's one of the things. It's an artistic and creative exercise. One of the things that I often say is, Picasso had paintbrushes and a bunch of goo on his little board, and he could throw paint on a canvas, and he could make really cool looking pictures, right? We don't have canvas or get to play with finger paints and stuff, but we have a keyboard and a mouse, and we use the creative side of our brain to produce these cool solutions to virtual problems, and we express ourselves with a computer programming language. So we are, in a way, artists, and we're learning to do things creatively. And if I ask every one of you to do the same program, my assumption would be I would get at least half a dozen different solutions where you take a completely different approach from somebody else. When the little fuzzies start going off in my head is when I see 8 people turn in the exact same code for the assignment. It's like, well, and I guess I have the same kind of reaction to Gary Kasparov, getting onto that topic, is if you're sitting here and I give you what I think is an interesting program, that by solving it shows me that you mastered this topic that we've been thinking of, and you turn in something that's just generated by an AI, I have the same reaction as Kasparov did. What was the point of that? That's not interesting to me. No, go away. Don't waste my time with that. I already know the AI can do these assignments. If you think I haven't plugged in these questions to the AI to see what it produces, no, I've done that, and usually it's several. Okay? That's not the point of this. If there was a robot that could paint a Picasso, I'm not asking you to go over to the robot and put it in front of the canvas and paint the Picasso. That's not interesting to me. What's interesting to me is seeing the light bulb come on in your head when you figure out how to do the towers of Hanoi and get all the little donuts to the other peg. Okay? Why waste your time? So if you're going to turn in something that an AI generated, just save us both the hassle and don't turn it in at all. That way I don't have to waste my time entering the zero and you didn't waste the time doing the assignment. Let's just skip that whole step. Just take the zero and move on. If you're here and you want to learn how to program, when it's busy work, well, I don't want to be sitting here doing busy work either. I mean, that's my only solution, is to give you so much that you have to spend, 6 hours of your time with the AI developing assignments. Again, to me, that just tells me you know how to click buttons. It's like taking a calculus class, and I'm trying to teach you how to do derivatives, and you enter all the problems in a calculator, and it gives you 7.24. Was that a good use of either one of our time? No, because you still can't go to your little brother and say, hey, I learned this cool thing called a derivative. Let me tell you what it is. I want to add to what's in your head. I don't want to just give you a video game where you can go click a bunch of buttons. Does that make sense? So if you turn in something and I give you a 0 for using AI to generate it, and I seem a little frustrated, that's why. Is because it just seems like a waste of your time and my time. So there we go. I'm here to have fun, give you interesting problems. Hopefully you can have fun solving the problems, and that's the point of it. Very soon, companies are going to look at things like college degrees, and they're going to wonder, does this person know how to enter problems into a UI and copy and paste a solution to their teacher to fake them out? Or do they actually know this stuff? And so you want to make darn sure that when you're sitting there in that interview chair that you can explain it, not just, well, if you give me 10 minutes on a computer, I can type it into the AI and get a solution for you. Because I'll tell you, little kids can already do that. That's not the fun part. I'd much rather you be the expert in the team. You want to be on the side of the line where you are using the AI to solve the problems for the computer. We had this saying back in my career at some point. I've heard it, that a fool with a tool is still a fool. So I will almost guarantee you that nobody's going to hire you to enter the commands into the AI. That's a minimum wage job. But knowing that you know and understand all these algorithms, and oh, you know what? That sounds like a pathfinding problem. Maybe I should use the A-star algorithm to solve that. Well, now I can ask the AI for an A-star solution to this problem. You know what the inputs and the outputs are going to be. Now you can get a good solution to it. You want to be on that side of the fence, not the minimum wage, enter the stuff into the AI and copy and paste the solution. So hopefully I'm going too far down that rabbit hole, and we can talk about stuff later in more detail. Okay, stuff you should have already learned by now: pseudocode, flowcharts. That's all COP 1000 stuff. I'm probably not going to have you do a bunch of pseudocode and flowcharts and turning those kind of things in, because I'm going to assume that that's prerequisite to this class and you already know how to do that. That's as much training your mind as it is knowing how to do flowcharts. Since the late 80s, I have not been asked to produce a flowchart as part of my job. Okay, so it's something that you need to train your mind how to do, and once your mind thinks that way in terms of the flow and the structure and the looping and the conditionals, good enough. You've checked that box, let's move on. You do need to understand that we're doing mostly procedural programming, even in Java. Java is considered a procedural program language, but it is also used in environments which are, we should call them event-driven or event-based. Common place where Java is used is in web services. So there are little transactional pieces of code that get called from a web request coming in. A piece of Java gets called to handle that web request and produces some HTML output. So, you need to understand things like that. We'll talk about more of that in detail later. And then, like I said, algorithms. Yeah, and think about this too. In what ways can I be a resource to you? That's why I don't spend a lot of time on my background, my career in detail. You're welcome to go out there and read it if you want to. If that's interesting and you think, oh, well, I'd really like to get a job working in the airline industry on their software, great, let's talk about that. Or, Expedia, they do a lot of travel type applications. It seems like 4 out of 5 travel websites out there are owned by Expedia anyway, so there's a lot of jobs out there, a lot of companies, a lot of websites under the Expedia umbrella. Maybe that's something you're targeting. If you see anything like that and you want to know more about that particular domain area, feel free to let me know. I'm happy to go into it with you. One of the things that I try to caution everybody every semester is that I don't see anybody in here that says, I want a 0 out of this class. Or, well, once in a while I do get an email from a student that says, I know I'm making an F or a D in the class, but is there some extra credit that I could do so I could at least get a C out of the class? No. I'm not interested in that. That's not interesting to me. It's not helpful to you to eke out of here with a C instead of a D. That's a boring problem for me to solve, okay? But most people don't start on the first day of school saying, I would really like to get a D in this class. What can I do to make that happen? Let's do it. But you do have other classes, maybe jobs, maybe families. You have other priorities in your life. And then other stuff happens. Your car breaks down, your dog bites your leg, other stuff happens. In this area of the world, we get a hurricane once in a while, right? Stuff happens. So usually the biggest things that cause people to not be successful and not get the A or B that they want out of the class is that you haven't thought about the goal. What is it going to take? What work am I going to have to do this semester in order to get an A or a B in this class? Okay, so think about it. Look through the modules tab in Canvas at all the stuff that we're going to try to cover and formulate a plan for getting through all that material this semester. Allocate your time each week, each day, every couple of days, whatever. Allocate your time when you're going to have time to focus and study without distractions and things, which leads me to the next bullet, distractions. Your phone. All the little social media apps that you're on. Video games. For me, that's a big one. I like my Xbox. I like spending time on my Xbox at home. You know what your distractions are. You know the things that are going to cause you to do that instead of your homework every week. Just make a note of those things that are going to affect you and manage them. Have a plan for managing them. Fine, I'll play my video game on Friday night if Thursday night I get my homework done. That sort of thing. Have a plan for managing those things yourself. And then procrastination. Okay, this week I got to focus on my English class because I got a big paper due in there, whatever. So I'm not going to have time to spend a lot of time on my programming class this week. Got it. I'm probably not your most important class of the semester. I don't assume that. When I was in college, I had teachers where I thought, that guy thinks that this is my only class of the whole semester, and he's given me 30 hours worth of work every week because he thinks I don't have anything better to do. I'm not going to do that to you. I've already laid out exactly what we need to get done this semester, and I think it's reasonable with the mix of your other classes in order to get that stuff done and get a decent grade. And for me, the grade isn't the point. I know it is for you. For me, it is, there's a certain number of things that I need you to know about Java. So when you leave here and somebody else asks you an interview question about Java and you answer them, they don't say, what the heck is Snyder teaching those people, because this person didn't know how to program themselves out of a wet paper bag. Those are my priorities. I want you to get this stuff to a level where I can say, yeah, that class of students, they are all proficient at Java. And I would be comfortable giving any one of them a problem representative of this area, and they would solve it. That's what I want. So manage those things yourself. Usually when I see people get in trouble and start using AI to do their homework and start racking up the zeros is when they wait till the last couple of weeks of school and then say, I need to turn in all these assignments. But now you don't have time to spend a couple of hours on each assignment solving the Towers of Hanoi problem and moving all the disks back and forth. You don't have time anymore. So what do? Maybe I'll just copy and paste the assignment into Claude or into ChatGPT and see what it gives me. Oh yeah, that looks pretty good. Let me change a couple of comments and turn it in. 0. That's when you get in trouble. So if you plan now and spread your time out throughout the semester, even maybe work a week ahead and start getting those assignments ready ahead of time. I'm not trying to sit here and trap you and surprise you and trick you. I want you to be successful as much as I hope you want to be successful. AI is a big thing. We've talked about that already. If I were you, I would be very concerned and be paying very close attention to what, in addition to being able to program in Java, you are going to be able to have to learn and acquire those skills in order to get a job when you're competing against AI and you're competing against, companies wanting to do it better, faster, cheaper, and not wanting to pay you good salaries. I had the benefit during my career of getting paid pretty competitive salaries. And if I went from this company to that company, I could probably count on getting a few $1,000s a year raise, right? It was pretty predictable. But I don't know what to tell you anymore. I wish I did, but we're all unsure of how this is going to shake out. Right now there are, what was the last statistic I saw? Something about 150,000 software developers in the U.S. Maybe somebody's got more accurate or more recent statistics that you've seen, but people that are mature, experienced software developers that have been laid off from good paying jobs at big companies. And I'll tell you, many of those people will never work in the software development field again. Not because they aren't good programmers, but because they don't have to pay you that much. I mean, yeah, if you wanted to go work for minimum wage, wear a little cardboard sign out in front of your house that says "We'll code for food," something like that. I mean, we joke about it, but I'm sure you've heard stories, your parents, grandparents, whatever, that lived in a town with a steel mill, and then the steel mill closed down because they are making all the steel in China or something, and hundreds of people that were there supporting their families, had mortgages, had car payments, now can't work and can't do any of that stuff. They don't have some other skill or some other career. They can't get an Uber job. What do you do? It's really hard. And there are hundreds of thousands of software developers right now in the United States in that situation. And you're going to be trying to get a career in that field, in that kind of an environment. It used to be, oh, your steel mill just got put out of business, well, learn to code. Now it's, oh, you're a software developer, learn to be a plumber, right? I wish I knew what to tell you. It's really painful out right there, right now, and I don't know what the solution's going to be. Used to be you could go down to the career office and say, hey, are there any career fairs going to be set up? Can I go and talk to employers? What about internships? And you could get things, and they would give you these lists of, oh, here's the top in-demand jobs across the country that, you should be targeting this kind of a degree. I got to tell you, I was, coming back to school this semester wondering how many students I was going to have, because, if you're looking at that list now, is software development even on the list? I don't know. Like I said, I'm asking you guys, what are you hearing? What are you seeing out there? Anybody? Like, why are you here? Why is Java something that's important for you to acquire as a skill? No thoughts at all? Did I scare everybody? You're going to go run and drop the class afterwards? Yeah.
Java seems to have, or from what I've seen, it seems to have like a strong foothold in the enterprise ecosystem, I guess you call it. And I guess if one is trying to get into that market, then that's what, or would be a large requirement to get into that field.
Yep. Yeah, all I'm saying is be aware of the pressures. College is expensive, and you're investing a lot of your time, your best years, when you're most capable of learning new stuff. Pay attention to the pressures out there in the job market, and have a plan to deal with it. Another thing that I would highly suggest, because we can talk about, okay, given the fact that I'm going to be competing as a new graduate against experienced developers or out-of-work developers who have a lot more deep resume than I do, what's going to make me stand out? And I always say a portfolio. It's not good enough to just wave your diploma and say, look at this, look at my GPA. They're going to want you to have a portfolio that shows what you have done, what you can do, what you are doing, and how that relates to the problems that they're trying to solve at their company. And one of the reasons why we use GitHub is that lets you start building that portfolio. So if you create each of your projects in this class and you check it into GitHub, you've started building up that library of software that now you can point to an employer and say, hey, here's the URL, look at my list of repositories that I've created, and you can click on each one of them and see what is this project about, what does it show that I'm able to do, what interesting twist did I put on it that I've been experimenting with, but you'll have a story to tell about what you can do, not just the little piece of paper that somebody gave you. Even certifications are becoming less interesting to talk about than what can you do when you actually sit down at the keyboard. You want to be like Kasparov, not Deep Blue, I guess. So Moving on from that heavy topic into more of the Java-specific stuff, and what we're going to be doing this semester. Learning a new program language often follows a similar pattern, which is we talk a little bit about the history of the language. Why so many programming languages? Well, many of them were started for a particular reason or to solve a particular class of problem because they just were kind of efficient at doing it sometimes. Sometimes languages were created out of spite. Well, I don't want to use your language, so I'm going to invent my own. Or some of them were done because, well, I don't have the money to pay for that language, so I'm going to create a free one that I can use. But, you know, there's different reasons, different etymologies for these programming languages. You know, different variations. But after we get through the beginnings, and I guess that just kind of informs why you will see us in the class talking about certain kinds of programs. Like it's a Java class. Java is very popular in open source or environments where they don't want to spend a lot of money on the tools. So you'll see like a Linux stack with a Linux server running Java programs that's in a web-based environment where internet traffic is coming to and from the server. It's just very commonly used for that. So that's why we'll talk about that kind of solution in this class, is because that's where the etymology of Java was and what it's good for being used in that kind of environment, for that kind of a problem. We will then talk about the tools and the frameworks. Java's got kind of a, you know, at the time it was pretty revolutionary. Now it's interesting to talk about how clever that environment is and how elegant it is to use a Java type language. C# has got a lot of parallels with Java, and so we'll talk about that. But you know, what are the tools? The compiler, the runtime environment, the editing tools, you know, some of the other commands and things associated with it. We'll talk about a lot of that kind of stuff. So that goes after the history part. And then we get into the syntax of it. What are the rules of the language? You know, if you're going to use, you know, talk Spanish, then you're going to want to know what are the nouns and verbs of Spanish. What's the order of the verbs and nouns, you know, relative to English that you're familiar with, that kind of thing. But we'll talk about the rules of Java and how to correctly write a Java program and compile it and get it to run. And then, you know, most of what programs do is they manipulate data in memory. And so we'll have to talk about how data is managed inside a Java program. So, you know, it basically just follows this flow, and, you know, this course is going to be no different from that. I'm not going to chart out some radical new way of teaching a programming language. We're just going to go through the same kind of order on stuff. And then you'll see me assign these programs, which are meant just to check that, okay, yeah, I understand that aspect of Java, and then we move on to the next thing. But some of the later projects, you know, I've created because I think that they're pretty interesting. And again, I'm always thinking in the back of my mind, if I assign you something and you do it and you expand on it and put it in your portfolio, it's something that you can point to say, hey, this is kind of cool. I was pretty proud of this. But, and like I was saying about the evolution of this course in the future, you know, the further we get into it, after you learn the basics of Java and how to write and compile and run a program, it becomes less about the language and more what can we use it for, what can we solve with it. Embedded, you know, so you do see Java used frequently for embedded projects in that kind of an environment, you know, mobile applications. And then if you're going to be a Java programmer, then I would encourage you to focus on the concept of DevOps, which is, so I built this little module in Java, but where is it going to run? So let's say we got this rack of servers over here, you know, and once we get it full of stuff and all the power's on and you see the blinky lights over there going crazy, then let's say we turn it on the internet. There's a difference in how you configure the code to run if it's just you in the classroom sending a request over there and getting a response back and yay, it's correct, versus if everybody in the class is hitting the thing at the same time. Well, maybe we need something with a little bit more processing power then to do that all at once, versus if we put it on the internet and 10 million people per day are hitting it, it's probably going to eventually exceed what one computer can handle. Then we got to start talking about distributing the load across a farm of servers. And then let's think, well, maybe those servers are going to need to talk to a database at some point. How is the database going to be able to support that farm of servers that are supporting the 10 million people out there? And so you get into these situations where you're spending most of your time not writing the Java code. It works. It's sitting there working. If I call it, it does what it's supposed to do. But how do I configure this environment to grow and shrink and handle the varying number of requests and demands that are made on the environment where the Java program is running? And we call that DevOps. And it's a very fascinating area. And once you learn how to do Java and other programming languages and stuff, DevOps is a great field to get into. It has its own set of tools and techniques. It's a little bit different than, like, let's say, the security stuff, in that my brain just went, what's the degree that we teach in this classroom that's on security? Cybersecurity, thank you. Yeah, it's slightly different than cybersecurity. It's keeping the stuff running and letting it expand, and there's a lot of scripting and a lot of development that goes on behind the scenes to let all that stuff happen. And if you're good at that, it's very valuable to a company to be able to do that. The team that I got laid off from at Microsoft, so I was in a group, probably had 100 people in it total, and this is QA people and program managers and admin staff and all kinds of people, let's say 100 people. I was one of the managers in this team, half a dozen different managers, and all of them got laid off, the whole department basically. There was one guy in my team that they kept, that they said, yeah, the rest of you are gone, but we're keeping him. Why? What skill, what value did he have to the company? He was the one guy in the team that knew how to log in to the router and change the lowest level settings of that router to configure how it handled the packets as they came in and out of the router. And if he left and something happened to the router, they'd be screwed. They would have no idea how to fix it. So he's the one guy that didn't get laid off in the entire team. So DevOps is one of those areas, like it or not, where you can be indispensable in addition to being valuable. Okay, just food for thought. Under there, logging and event reporting is very important. So we'll really quickly figure out how to write Java programs and get them to run and do some interesting stuff with them. But I call this aspect-oriented programming, where you take a piece of software and then you add some other aspect to it, like logging. What if you wanted to know, you got this server sitting over there and it's got all of these copies of Java programs sitting on it running all the time. But you want to go to some web page and you want to see, tell me how many times that Java code got run. Well, how are you going to be able to find that out? You go to this web page and you look at it, and what's going to be on the web page? What you really need for those Java programs to do is every time they get called, log, hey, I just got called to some database. And then right before they exit, say, okay, I just finished and I'm getting ready to return. Okay, now I've got a web page over here where I can say, show me how many times that those log entries got put in the log. Okay, so logging is an important aspect of programming in languages like Java that makes it work better in a server farm type of environment. It makes it where you can operate the software easily. Same with event reporting. Hey, something just broke unexpectedly. Throw an event. So somebody on some monitor can watch for, hey, a little red light started blinking that said some event started happening. Maybe somebody tripped over the cord and we should go plug the network cord back in. Stuff like that. But lots of different stuff. I could go into each one, but I don't need to. But the DevOps and writing your software so that it behaves in some kind of an environment like that is also another aspect we can talk about. Okay, so peeling the onion a little bit back. So like it says, Java is about 30 years old. You can look that up in Wikipedia. I keep getting older, so I have to keep updating those numbers. But, it's about 30 years old or so. Oracle's still a company out there. My nephew works for Oracle as a software developer, so it's still around. This guy, James Gosling. I kind of find it interesting to point out names sometimes because, give the guy some credit. One of these days maybe you'll invent something and you want somebody in some classroom somewhere to say, hey, that's the person who did this. So, give the guy props. Hey, he invented Java. A lot of people like Java and use it. So at the time it was, hey, we have this need to I want to run the software, write the software once, and I want it to be able to run in a whole bunch of different diverse kind of environments. And I could get into it in detail. It might not mean anything at this point, but one of the elegant things about the Java language is that it runs on top of what we call the Java virtual machine. And okay, well that's not that interesting, except that at the time when Java was invented, your options were, if you're going to write code for, let's take the flight simulator, Microsoft Flight Simulator. It's a cool little game, piece of software. But when Microsoft shipped that, they had to ship a different version, which a different team of programmers wrote for the IBM PC and the Apple and the Commodore 64 and every single platform out there that existed that you could buy as a consumer. If you wanted to play Flight Simulator, Microsoft had to write a completely different version of it to run on that platform. The cool thing about Java Virtual Machine was it let somebody like the team writing Microsoft Flight Simulator, they could write the software once. Then you had to have a very clever person write a Java Virtual Machine for the IBM PC, and one for the Commodore 64, and one for the Apple, and etc. for each of those platforms that were popular. As long as there was a Java virtual machine on that platform, you could run your Java program on that platform. So, yeah, it took a lot of time and thought and cleverness to come up with the Java virtual machine implementation on each of those platforms, but all they had to do was solve that problem once, and then thousands of programmers out there could write Java programs comfortable knowing that their software was going to run on all these different platforms. It was really cool, very clever, very ingenious, and very useful, and it was immediately popular. C# I mentioned earlier. It took several years later, they took a similar approach. Microsoft was very happy getting people to buy C++ as a language, and develop programs in C++ to run on their Windows and DOS platforms. But they wrote C#, and they wrote something akin to the Java virtual machine called the Common Language Runtime, CLR. And it's a similar kind of thing. You could write a C# program, and as long as the environment had a common language runtime that would run on that platform, your C# program would run on that platform. So similar kind of thing. Okay, so in our classroom, the tools that we need are already there. It's nice, but there's something to learn about sitting on a machine that doesn't have Java and installing the tools that you need to get your program to run, and understanding where they come from, where you download them from, and setting them up, configuring them, and then getting your program to compile and run on that machine. You don't have to do all that here. All you really have to do, we'll see that in a minute, is you just create a text file with some Java code in it, compile it, and run it, because they've already done it. So how do you know whether your computer already has it? So I can go to a command prompt, and if I type Java version, instead of saying, I don't know what you're talking about, it says, oh yeah, the Java version is 1.8. Let me zoom in that a little bit so you can see it. So it gives you a blob of stuff, and whether you understand what this all means or not, what it means basically is that when I try to type Java, it knows that command. Which means somebody downloaded the tools, they installed them on this computer, and they added the location of java.exe to the path so that when I open the command prompt, it already knows where it is. Yeah, so that's where whoever set up these machines, that's where they installed Java. Okay. On your machine at home, maybe it's in the same place, maybe it's in a different place, but if you go through the similar steps, you'll have Java and it'll be located someplace on your computer. So that's what it means to have Java installed, is you just have those commands available to you and you can find them when you need them. Another thing that you can do, if you don't want to do that, I can't really zoom this in, but there's a registry key in here. JavaSoft. Yeah, so you can come in here and you can find the registry key, HKey current user software JavaSoft, and that will tell you where the settings and stuff for Java are. I think one of these is going to tell me where the install location is. It should. I don't see it. Maybe it's under local machine instead of current user. Yeah, there we go. There we go. Yeah, so HKey local machine, software, JavaSoft, Java runtime environment, and then under the version that's currently installed, you'll see where the Java home is, and that'll tell you where Java is installed to. Okay, so that's another way to know. So when you install the Java tools, it sets those registry keys. That way Windows knows where to go to find it. If I wanted to create I don't know what that is, but if I want to create a Java program, I guess I'll have to type it. Thought I could copy and paste it so you get to see my bad typing skills. Okay, so I typed in some gobbledygook there. Basically all I'm doing is saying, hey, print to the screen the words hello world. And I had to put some boilerplate around it because that's just what Java expects. And I can save it someplace. Let's say I put it in my downloads. helloworld.java. So all I needed was Notepad, right? I ran Notepad, I typed some of this stuff in, and I saved it somewhere on my computer that I could find. So now I can come back here, downloads, is that where I put it? Yeah. Okay, so now two things. Number one, I have to compile my program. Wait, no Java C? Okay, so I have a whole bunch of Java compiler instances installed on my machine. Android, don't even know what that is. WebStorm, PyCharm, IntelliJ. Let's go with this IntelliJ one. That'll be interesting. So that should be in my path. So let's put that in my path. Ah! Well, it is Hello World. Does it care about the case? Surely not. I guess it does. Okay. Note number one. The Java compiler is case sensitive when it comes to the file name of the Java file. Okay, so now I've compiled it. To run it, I have to just run hello world.class. Hello world.class is the file that it was created when I compiled hello world.java. Really? There's Notepad. Huh. I wonder if it's a version issue. Well, so you saw back when I looked for all of the different places where Java C was found on the computer. One of the things that you'll run into here, I guess, and at home, is that if you have multiple copies of the Java runtime environment and the Java compiler, you have to use a compiler version that's compatible with the runtime environment version, or interesting weird things will happen. Well, so my point here was simply to try to say, look how easy it is to create a basic Java program. All I needed to do was create the file in Notepad, text file, compile it, and then run it, which is true. It's just that we run into this error, which I'm kind of bored and don't want to try to figure out right now. But that's my overview of what the basic tools are. The next point is, because those problems are boring and irritating, and I get annoyed that they occur at all and don't have much fun trying to figure out and get the right version of the compiler in the path and all that kind of stuff, it's a lot easier if you just download an IDE, the integrated development environment that includes all those tools and sets up all those paths and all those other little requirements and stuff and dependencies behind the scenes. We haven't even talked about libraries yet. When you start talking about writing your code to depend on libraries that do interesting things, managing the versions of all those things too. We used to call it DLL hell in C++, but it's a similar concept in Java and C#. It's just we don't call it DLL hell. It's library hell, I guess you could call it. But versions of things have to be compatible and have to work together. So on these machines, we have IntelliJ installed, which I like it. It's a commercial product that you can create to you can run, install and run and use it to create these interesting problems. And see, I already opened a ticket for this, but this is what we run into right now on this lab, is they installed the tool, they require us to log on as a certain user. I can't log on to this machine as me. And then they don't activate the license to the tool on the machine for that user. So I opened a ticket for this, and hopefully IT will come along before next week and fix this. My guess is if you run IntelliJ on the classroom machines, you'll hit the same problem. Now, I do have my own license to IntelliJ, and I could go look up that information. I could paste it in here, and that would work for this class. But like I pointed out earlier, once I restart the computer, all that goes away, and so the next time I come to class, I have to paste the information again. That's a perfectly fine model, and we might actually use that. Because one of the things I want to point out to you is that you can get a student version or student license key for IntelliJ. It's a very powerful editor, very useful, and as a student you can get it free for a year. So why not? Why not go out there and sign up for it? And then you'll have your little your activation code that you can paste in here when you get to class, and boom, IntelliJ will work for you for that class session. So along with managing your files like we talked about at the beginning of class, managing your IntelliJ subscription token and entering it each class might be something that you do every day when you get to class. So hopefully I'll be able to show you more about that next time when they fix that problem. Eclipse is another IDE just made by a different group of people. It's a little older than IntelliJ. Visual Studio Code is a Microsoft tool that you can use that supports Java if you add the extensions. Haven't tried Eclipse or Visual Studio Code on these machines to see if they're installed or configured or licensed correctly, but you're welcome to try to play with those if you want to. I think Visual Studio Code's got to be on these machines based on what I know they require for other classes. So feel free to play around with that if you want to. And in the end, just use what you're comfortable with. But like I said, be very, very careful, because they keep making these tools more powerful all the time, which means what? They're going to include a bunch of AI features, which are going to encourage you to use those AI features, which are going to make you prone to getting zeros after doing all the work. So just be careful going down that rabbit hole. When you see AI or see something suggesting how you solve the problem, just say, no, that's not what I'm here for. I don't look at the newspaper. Well, of course, I don't look at newspapers anymore anyway. But if you scroll to the funnies page and look for the crossword puzzle, nobody rushes to get the newspaper off the front porch so that they can open it up to the crossword puzzle and look at the answer key down at the bottom and fill in all the answers. That's not the fun part, right? The fun part of it is doing the puzzle. So just be very careful when you start seeing these pop-ups and these AI features and co-pilots and things like that try to do the work for you. No, that's not what I'm here for. All right, just push them away. You know you can do that. I want to know you can figure it out. Okay, so peeling the onion back a little bit more. So this is going to just be an intro, and we'll get into more of this as the course goes on, but talking about the syntax. So when we use the word syntax, we're just talking about the rules of the language of Java. Where do I put the curly braces and the semicolons? What do I have to capitalize, and what can I get away with? That sort of thing. So C++ came before Java, so you'll notice naturally that the syntax of Java in many ways resembles C++, because kind of, you're trying to sell Java compilers to a bunch of C++ developers. You want to make it easy for them to understand and come over to your side of the fence, right? So it's natural. It borrows a lot of syntax from C++. One of the first things we need to know is how to add comments. Again, common to any programming language, one of the first things you learn is how to add comments to my code in that language. In Java, like C++, if you want to do a single line comment, just start your comment with //. If you type a bunch of code and then at the end of the line you say // everything from there to the end of the line is a comment. Doesn't matter, the compiler's going to ignore it. If you want to put comments inside one line, then the /**/, anything you put inside there is a comment. The compiler will ignore it. And then the other one is sometimes you get tired of typing all those slashes and stuff. So if you just type /*, you can type multiple lines of comments and then finish on the last line with */, and now you're back to code again. So those are the three variations of how you can create comments. Knock yourselves out. Here's my hello world class that I was trying to type in. It's very possible I just had a typo in it too, I don't know, but this is not terribly advanced. This is the boilerplate. This is a simple hello world program that you'll start with pretty much every time, and then you'll start filling out your code inside there. You notice that I've got a couple of comments in here, and if you watch, you'll see this is pretty consistent with my style of programming, my programming style, is that I like to have this running narrative to myself. Because I just assume, I write so much code, that a week from now I'm going to come back and look at this and think, what the heck was I doing there? So if I have these little comments to myself in my own words, it helps me remember what this was for. So I encourage you to don't just write the code, but tell yourself what you were doing, what you were thinking when you wrote this. It'll be a good reminder for later. Maybe your memory's a lot better and more reliable than mine is these days, but that helps me. And it also helps other programmers. When you're working in a team environment and you open somebody else's code and you see that they commented it, you're like, oh, phew, I won't have to figure out what the heck they were trying to do here. Yeah, like I was trying to do, you save it in a program called Hello Java. As we know from watching my mistake earlier, if the class is called Hello World, then the source code needs to be called hello world.java, case sensitive. Then you compile it, and then you run it. You should see Hello World on the screen. Tried to do something very easy and still screwed it up, so there you go. And like I said, that was just an intro, just to get you started, do a little bit of stuff. And like I said, next I would look under modules in Canvas, and you can start reading the first chapter. It'll probably ramp up pretty slow at first, more generalities of the language and stuff. You'll see in Canvas, let me see if I can bring up Canvas real quick, under modules. Module 0 is the pre-stuff. It is a lot of course overview, instructor info, that kind of thing. The textbook. When you see these links out here that says lecture, sometimes I've got a recording out there already. Sometimes, like this one, I'll put the recording up after the class is over with.